Welcome to Lesson 31, Problem 2 of Engage Math, where we are looking at quadratic functions and a specific type where we have a projectile motion type problem. And this is really common, kind of a classic word problem that's used when you're studying quadratics, which we are doing. So when a ball is thrown into the air, it's going to take this parabolic shape. Now, you might be thinking, well, it kind of looks like a circle a little bit to me, but if we continued, we'd end up getting a parabola, and there would be a highest point in this parabola. So let's kind of see, based on the equation, and of course, this is just a sketch, but we are going to try and figure out different information based on the equation that's given. So this is just our sketch that we're going to use, and I'm going to zoom in so you can see everything for A, B, C, and D, which all really belong together. So we're going to start by finding the height of the ball at 0.5 seconds, which is a half second. So we're going to say h of 0.5, which we know is read as 5/10, is equal to -16. And we just put the value for t into our function. And when we do that, 0.5 plus 5. When we do that, we're going to get that the height after 5 seconds, just substitute all of the 0.5 in for every t, and when you simplify, you're going to get 25 feet. Now remember, you can do these problems on your calculator. So 25 feet should be your answer. Okay, let's go to part B. So for part B, it says, after how many seconds does the ball reach its maximum height? So what we know is that the maximum height is going to be at this vertex. And the way we find the x-coordinate of a vertex of a parabola is by doing the opposite of B over 2a. In this case, it's going to be the value of t. It's going to be how many seconds it takes to get to that highest point. So what we're going to do is we're going to say a is going to be -16 and b is 48. If we look at this equation, our function right there. So I'm going to put down -48 over 2 times -16, which is -32. You can reduce that because you have the calculator this time, so it's 1.5 seconds. So it's 1.5 seconds. All right, so now we know that right here at 1.5 seconds, the ball is at the maximum height it will ever be at. And that would be like the x, or in this case, the t coordinate of the vertex. So to get the y, or the h of t coordinate of the vertex, we're going to put 1.5 in, or 1.5 in for t. So this time we have -16 times 1.5 squared plus 48 times 1.5 plus 5. Okay, now when you simplify all this, and once again you can do it on your calculator, you should get 41 feet. Okay, let's go to D. Now it says, without substituting into h of t, which we could do, what will be the height of the ball after 2.5 seconds? Now, what they don't want us to do, even though we could, is we could find h of 2.5. But what they want us to do is use some logic that we already know. So I'm going to go back to our drawing. I'm going to put 41 in here. And we already know that somewhere around here, and again, everything's just a sketch, we have a half of a second. So at 0.5 seconds, we had a height of 25 feet. So what we know is, since everything is symmetric about the axis of symmetry, which goes through the vertex, if it took us 1 second to get from here to the vertex, from the height of 25 feet, we know that we will once again, at 2.5 seconds, so 1 second after we hit the vertex, we will once again have a height of 25 feet. So after 2.5 seconds, the height is again 25 feet. So we could have substituted in and we would have gotten 25, but we also know, based on symmetry, the answer without substituting in. Okay, so now I'm going to go and look at parts E and F because they get a little tricky. All right, so when will the ball be 37 feet high? So what we're going to do is we're going to this time put 37 in for h of t. So 37 equals -16 t squared plus 48t plus 5. Because we want to know what value of t how many seconds until the height is 37 feet high. Now, I'm going to go back to the drawing for just 1 second so you're kind of thinking ahead of time. I'm going to kind of think of it as we know it's going to be somewhere around these 2 green points. So there's going to be 2 values of x or t when the height will be 37 feet. You can see that by the drawing. So let's go back, and what we're going to do is we're going to say 37. So I'm going to make this 0 by subtracting 37 from both sides. So 0 equals negative 16t squared plus 48t minus 32. I don't like dealing with all those huge numbers, so I'm going to divide everything by negative 16. So if you divide everything by negative 16, I'm not going to show all those steps, but you're going to get 0 on the left. Negative 16 divided by negative 16 is just going to give us t squared. 48 divided by negative 16 is going to give us minus 3t. And negative 32 divided by negative 16 is going to give us a plus 2. Now we can factor, because we know this is just an AM factoring, and we have t minus 2 and t minus 1. Because negative 2 and negative 1 multiply to positive 2 and add to negative 3. So our two answers are t equals 2 seconds and t equals 1 second, because you set each one of these factors equal to 0 and solve. So we know the height of the ball will be 37 feet after 2 seconds and after 1 second. And I know I went through that a little quickly, but it's a light bulb problem. So if you're working that one through, this is good math for you to see. Let's go to F. Now we want to know when the ball will hit the ground. So I'm going to write out our original equation, negative 16t squared plus 48t plus 5. And this time I'm going to set the height equal to 0. So this problem is not going to be nearly as easy to solve as the one on the left because it doesn't factor. So what we have to do is we have to go to the quadratic formula. So when we do that, we're going to say t equals, because our variable is really t. So just to remind you, a is negative 16, b is 48, and c is a positive 5. So we're going to say t equals negative 48 plus or minus the square root of 48 squared, because it's b squared, minus 4 times a times c. And by the way, if you forgot the quadratic formula, you can look at the inside back cover of your workbook, and the formula is there. So it's b squared minus 4 times a, which is negative 16, times c, which is 5, all over 2 times a, which is 2 times negative 16, or negative 32. All right, so now you get to use your calculator and enter all of that in. But just to make sure, I'm going to do a little bit of the work with you. So we're going to say negative 48 plus or minus the square root. Now, on your calculator, I just want to make sure you enter that right. It should be, if you can enter this all in one, like kind of one keystroke, or like one screen on your calculator. You don't have to press enter equal in between. But it's 48 squared. And then it's going to be the minus 4 times the negative 16 would make it a positive. So it's going to be a 64, because that's 4 times 16 times 5. And when you do that, the number that you get inside that radical is going to be 2,624. Okay, and all of that is still over negative 32. So now what you want to do is you want to say, all right, well, what if I took negative 48, and the first time you're going to say negative 48 plus the square root of 2624, and then press enter before you divide by the negative 32. Then you're going to do the same thing, and you're going to do negative 48 minus. So the second time you're going to do minus the square root of 2624, and then you're going to press enter before you divide by negative 32, or you can put all of this in parentheses and then just divide by negative 32. But you have to make sure that you indicate to the calculator that everything in this numerator has to get divided by the negative 32. Okay, so the two values that you should get then, you should get one will be negative and one will be positive. The one that you want is the 3.1 seconds. And the reason that you get a negative and a positive answer, Sorry, that's 3.1. I'm going to go back to the drawing and just to show you. So somewhere around, 3.1 seconds, we hit the ground. The other answer that was negative was before the ball was up in the air. It's giving you this value of t. So that was before the ball was even thrown, because it's kind of like the parabola continues to go to the left as well. But the only answer we want is 3.1. All right, thanks for joining us here today at Engage Math.